Welcome to The Explainer. I'm absolutely thrilled to have you here today. So, if you've ever found yourself wondering how the digital world communicates behind the scenes, you are definitely in the right place. Today, we're embarking on a really comprehensive, step-by-step journey into the core mechanics of API testing. We're going to transform what can sometimes feel like a dry technical subject into a fascinating exploration of the invisible backbone of modern software. We're covering all the details, straight from the source, to give you a true crash course.
Okay, let's take a quick look at our roadmap for today. We're going to cover why use API tools, decoding URLs and URIs, understanding API endpoints, the core HTTP methods, reading HTTP status codes, and finally, the different types of API testing. All right, let's just jump right in.
Section 1. Why use API tools? We're moving testing beyond the web browser. Now, before we get into the weeds here, we really have to ask a fundamental question about how we actually interface with APIs in the very first place.
So why can't we just test APIs directly in a web browser? I mean, it's a totally fair question, right? Browsers are absolutely fantastic at rendering web pages for us, but they severely restrict our ability to actually test the underlying mechanics. I mean, sure, if you open up the Network tab in your browser's Inspect tool, you'll see API calls happening in real time. But can you actually intervene? Can you mess with them?
Well, the short answer is no. Browsers basically limit our testing to what we call the happy path. They just don't let you easily swap a GET request for a POST request to see what happens. You can't easily manipulate that payload data, like say intentionally sending over bogus login credentials just to see exactly how the server reacts. You're pretty much stuck as a passive observer. And to be an effective tester, you absolutely need specialized tools that unlock full request modification.
And that brings us to the tools of the trade, which map directly to very specific use cases. Take Postman, for example. It's kind of like your remote control for APIs, absolutely perfect for functional testing and automation. But, hey, if you need to test how an API handles massive user traffic, you're going to want to switch over to JMeter for performance and load testing. Need to spy on network traffic going in and out of your machine? Fiddler is your go-to for debugging. Meanwhile, Swagger is basically the industry standard for API documentation. And Ready API, that's what you bring in for heavy-duty enterprise security and SOAP or REST protocols. Like they say, you wouldn't use a hammer when you need a screwdriver, right?
Moving right along to Section 2, decoding URLs and URIs, or the anatomy of a web request. So now that we have our tools, we really need to figure out how to aim them at the exact right targets.
This is a debate you'll actually hear a lot in the industry. URI versus URL. Think about it like this. Amer Fort is a beautiful, famous palace in Jaipur. If I just say Amer Fort, I'm identifying it by its name. That is a URI, a Uniform Resource Identifier. But if I actually want you to go there, I have to give you the exact street address, right? The GPS coordinates. That specific address is the URL, the Uniform Resource Locator. So the really crucial takeaway here is that all URLs are technically URIs, but a URI is just the name, whereas a URL is the exact specific address required to actually find the thing.
Let's slice a URL into its core components step by step, so we can literally see the anatomy of where our request is going. It always starts with the protocol, right? Like HTTPS. Then comes the domain, your main destination, something like www.example.com. Now, sometimes there's a port number, like 443, which kind of acts like a specific room number in a massive hotel. Then you have the path, which points to the exact resource, like /demo/file. And finally, the query parameters, like location equals hide, which lets you filter or pass very specific data directly to that resource.
All right, Section 3, understanding API endpoints, specifically base URLs versus tail URLs. Now that we can read a URL like a total pro, we need to clarify what an endpoint actually is in the real world.
So an endpoint is the full, complete URL that you hit to make something happen. But it's actually made of two distinct parts. First, the base URL. This is the static domain, like https api.site.com, and it rarely ever changes. Then you have the tail URL, which is the dynamic path attached to the base, like /users page equals 2. This part changes all the time depending on what exactly you're trying to do. And here's a quick pro tip for you. Developers will often only write the tail URL in their documentation, just to save space. But you've got to remember that the true functional endpoint requires combining that base and tail URL in your testing tool.
Which brings us to Section 4, the core HTTP methods.
executing the action. We've got our tools, we've got our target, now it's time to pull the trigger. How exactly do we tell the server what we actually want it to do with our endpoint? Well, we use HTTP methods.
These core methods explicitly tell the server what action to perform. A GET request is basically like asking, hey, can you show me this? A POST request says, here's some brand new data, please create something with it. Delete is, well, pretty self-explanatory. But then we have put and patch, and both of these deal with updating data.
Now let's clear up a massive point of confusion in the industry by contrasting put versus patch. Imagine you have a user profile with a name, an email, and a physical address. If you only want to update the address and you decide to use a put method, you still have to send the name and the email back to the server alongside that new address. If you leave them out, put might actually overwrite them with blanks. Yikes, right? But with patch, you only send the exact, specific piece of data you are trying to change. It is strictly a partial update. Super important distinction there.
Moving into Section 5, reading HTTP status codes, or interpreting the server's reaction. Because once we execute our method, the server is going to reply, and we need to know how to read that result, which brings us to the fascinating and sometimes frustrating world of HTTP status codes.
Now, if you've ever stumbled onto a 404 page while browsing the web, you actually already know a little bit about this. But let's simplify the main categories. I want you to think of ordering at a local tea stall. This analogy perfectly humanizes the 5 main categories of server responses. The 100s basically mean, hey, I'm working on your tea. The 200s mean, success, here is your tea. The 300s mean, the tea stall moved to a totally new location. The 400s, that's a client error. That's on you, like walking up and asking for a flavor of tea they don't even sell. And the 500s, that's a server error. The tea stall stove is completely broken, they can't do anything for you.
Let's zoom in on the 2x success category for a second, because it's really vital to differentiate between these three. A standard 200 OK is exactly what you want to see when you fetch data. But if you use a post method to create something brand new, you should actually expect a 201 created. And if you delete something successfully, well, the server doesn't really need to send you a file back, right? So it'll often just respond with a 204 no content. Basically, it's saying, I did the job in silence.
All right, our final section, Section 6, Types of API Testing, Scaling Up the Methodology. Let's see how we take these individual interactions, the methods and status codes, and scale them up into a broader, much more comprehensive testing strategy.
Because a truly robust API testing strategy goes way, way beyond just checking if something turns on. Testing the happy path is just functional testing. We absolutely positively have to do negative testing, intentionally trying to grate things by sending invalid data. Then we do performance testing, using tools like JMeter to see if the server crashes under a heavy load. We do security testing to hunt down nasty exploits like SQL injection vulnerabilities. And crucially, we really have to look at the big picture with integration testing.
Because unlike unit testing, a single API in a vacuum, integration testing ensures the entire plumbing of the application actually works seamlessly together. Think about an online store, okay? It's not enough that just the Add to Cart API works. Does the Cart API successfully pass that data over to the Payment Gateway API? And then does the Payment Gateway successfully trigger the Email Confirmation API? Integration testing tests that entire end-to-end multi-step flow.
And honestly, that brings us to the ultimate takeaway of this whole explainer. If APIs are truly the invisible backbone of modern software, what kind of massive vulnerabilities are we leaving wide open if we only ever test the happy path through a browser? Mastering these specialized tools, really understanding URL structures, executing precise HTTP methods, and correctly interpreting those status codes, it's not just technical trivia. It is literally the only way to genuinely stress test, secure, and safeguard the applications that basically run our daily lives. So, what unseen flaws are hiding in the APIs you rely on every single day? Something to think about the next time you click Login. Thank you so much for joining me on this deep dive.